Good afternoon, everyone, and I am Dr. Kiran Sri, working as a professor in the Department of Computer Science and Engineering at Sri Vishnu Engineering College for Women, Bhimvaram. And my topic today is Identities of Regular Expression, which is a very simple concept where it will be useful for people who are aspiring for competitive exams like GATE. So I have organized this presentation like this. I start with what exactly is a regular expression, followed by some examples of regular expressions and applications of regular expressions, followed by the identities of regular expressions. Regular expressions are used to denote regular languages. We have many missions in theory of computation, like we start with DFAs, NFAs, followed by NFA with epsilon moves, then PDAs, LBAs, and finally we reach tuning missions. So every mission will have a language. So when we consider DFAs and NFAs and NFA with epsilon moves, these three missions will accept a language called as regular language. So a language consists of set of strings that can be accepted. When all the set of strings are represented with a common expression, that expression we call it as regular expression. So pattern of strings accepted by a finite automata is a regular expression. So when we represent regular expressions, we use many symbols called star, plus, and R, and many other symbols. So what is a star is set of all the strings that can be derived from input A starting with length 0. So epsilon is a string with length 0. So A star will contain epsilon, A square, A cube, and so on and so forth. So a regular expression A star, B star denotes any number of A's followed by any number of B's. The second regular expression denotes a mission has to accept strings which can start either with A or B followed by any number of C's ending with a single D. So the third, you can see the diagram where Q0 is a starting state and Q2 is a final state. Q2 is accepting strings ending with AB, but you can have any number of A's or B's at the starting of the state like Q0. So the regular expression for the above diagram is A plus B star AB, which is a machine which accepts strings ending with AB, defined our input as A and B. We have many applications of regular expressions. Whenever we perform such operations on a huge data sets, when we want formatting, like I need a student ID to be 10 numbers and it has to start with some character or something, whenever this formatting matters, we use regular expressions. Whenever we need pattern matching, particularly in machine learning, we use these regular expressions. We have special packages in Java as well as Python, which will encompass these regular expressions. In particularly when we are working to analyze the Twitter data sets to predict the variations of stock, we use this Python in a package called TensorFlow. This regular expression can be given as an input for various tools like Lex and Flex, where you give a regular expression and the action to be performed. These tools will recognize these regular expressions. Many applications are there for this regular expression. That is the reason this is the most important aspect of theory of computation. So these are the identities of regular expressions. Whenever you consider a decimal number system, you consider 0, you add 0 to any other number, you get the same number. Likewise, 5 is an empty set. You add an empty set to a regular expression, you get the same regular expression. Epsilon is an empty string. So in your decimal number system, you have 1 multiplied with 5 or any other number results the same number. So epsilon concatenation with R will result R. 5 concatenated with a regular expression will get a 5 because 5 is an empty set. So all these distributed laws will hold good for regular expressions like L into M plus N is Lm plus Ln, and the same next formula is also hold good in regular expressions. Same important law that we do. We add two languages or two regular expressions will result the same regular expression. So we are witnessing the laws of closure now. So R star whole star is R star. You take a regular expression, perform closure operation on it, and you perform a closure operation on R star, you'll get the same R star. Whenever star is there, you will have an epsilon. So phi star will have an epsilon. Epsilon star will also have a phi. R star is nothing but R concatenated with R star, and R star concatenated with R is nothing but R plus, where R plus is set of strings with minimum length string as 1. So R star is set of all the strings which are more than 1 plus an epsilon. So epsilon length is 0. So R star is nothing but R plus an epsilon. To summarize the things we discussed about the identities of regular expressions, we can say phi plus R is R union the empty set with a regular expression, we get the regular expression. Phi into R is phi. Epsilon into R is R because epsilon is an empty string. Epsilon star is epsilon because whenever star is there, you'll get an epsilon. You add two regular expressions, you get the same regular expression. That's what the important problem says. The important rule says R star will have an R star. You have a closure of regular expression concatenated with the closure of the same regular expression, you'll get the same regular expression. R star is nothing but R plus is equivalent to R star R. You take a regular expression, apply a closure on it, and you apply a closure on the same regular expression, you get this R star. So epsilon plus R star or epsilon plus R plus is nothing but R star. We have seen this PQ star P is P into QP star because both of them representing the same language. When two languages are same, two missions are same, so these two expressions are same. So P plus Q whole star is P star Q star whole star, and the same things holds good. So P plus Q into R is PR plus QR, and R into P plus Q is RP plus RQ. That we have seen these statements. All these are identities of regular expressions. And thank you very much, ladies and gentlemen.